If you went through, oh, and this is, oh, I'm really happy you're asking this one. This is a really important one to do right before the lab. We have to do this 3 times in the lab. So if you do not get 6 or don't understand how to do 6, then it's important to know how to do that before we get back there. So the question is, how many grams, and you guys have this right in front of you, how many grams of sodium nitrate are needed to prepare a 2.4 liter solution, that solution being 0.10 or 0.01 molar. Okay, so anytime I give you liters in molarity, what do you guys have to do with that? Right, when you multiply them collectively together, M times V, what does that always provide you? What unit? Moles. And that's not just you're memorizing, oh, I know M times V is moles. Like, that's a common mistake we just like to memorize. Really what we should do is say, okay, what's molarity's units? What's the units of this molarity? Okay, so 0.010 moles of who? Sodium nitrate, provided in 1 liter of solution. Well, we're making a whopping 2.4 liters of that solution, right? So we're going to have a lot more moles than what's present in 1 solution. So that's why we're multiplying to indicate that. So that times 2.4 liters, what cancels? Liters. And what do we get? 0.024, right? So you said moles of sodium nitrate. And you actually don't have to stop calculating moles. It's just nice to know that you're on the right track. But here, the question's asking for grams, right? So what would be my final step? Convert that to grams. So this, I don't know the molar mass, I'm depending on you guys. 0.024 moles of sodium nitrate. What is it? 85 grams per 1 mole. And that's our, it should be our final. What is that? 0.04 grams. Perfect. So as it applies to our lab, what in the world are we doing with this? Like, how would I actually prepare that solution that was requested to be prepared in number 6? Okay, so you'd measure this out on a scale, 2.04 grams, and then do what? All right, hon, so take 2.04 grams of sodium nitrate, and where would you put it? There's a very specific piece of glassware we always use in solution making. Everybody, help me out here.
The volume?
Yes, the volumetric flask, right? There's a specific volume. There's like, they come in 10s. Here's my Barbie one. Hold on. They come in little bitty ones like this. Look how cute it is. Look at the little beaker that goes with it. It's like a toy set. So they come in little tiny ones all the way up to 2.4 liters to 3 liters to whatever size you want. But it's only accurate based on the description on the flask. So this is a volumetric flask that says 10 milliliters. There's a teeny tiny echelon between the front. You probably can see that echelon. But that's, we have to use exactly the size that we want in order to prepare what we're provided with. So what size would we use here? Number 6, what size would we use? What size solution are we making? 2.4 liters. So we get a 2,400 milliliter volumetric flask, and we take the 2.4 grams and put in a 2.4 liter volumetric flask. And then what would we do? Because now we have a flask, some powder in the bottom. What's the solvent we're likely using? Water, right? So how much of that am I putting in? Until it reaches the etched line. We might need to review. You guys are not really helpful at this point. So before we do our lab, we're going to do a little review. So we would fill with water until the 2.4 liter etched line. Okay, I'll provide you with another scenario. Ready? I'm going to write down the details because I'm going to forget what I said again. I want you to prepare a 100 milliliter sample of a 1.2 molar sodium chloride solution. I want you to prepare a 100 milliliter sample of a 1.2 molar sodium chloride solution. I want you to figure out what we need to prepare it and write down how you would prepare it. Sodium chloride, yep. And while you're doing that, I'm looking for 1 through 18.
No, I couldn't get the
Solution?
yeah.
Raise your hand, can you calculator? Riley's table, get me started. What am I doing here? So take this to liters, okay? So that's 100 liters. Got it? So are you setting up a proportion? Okay, we're going to try our best to avoid proportions because we have stoichiometry that we can always use. And stoichiometry is just dimensional analysis, which is just unit cancellation. So my bet is like that percents are basically like proportions because that's understandable. Like I know on one of the problems you guys did X over 300 milliliters and you made it equal to percent. I'm going to try to use this number and this number together to do stoichiometry. Because basically what you're telling me to do, I think, is moles over 0.1 liters. And you're setting that equal to 1.2 molar, right? Well, what are we going to do to solve for X? We're going to multiply, so why don't we just start with multiplication? So I'm going to start with 0.10 liters times molarity, which is 1.2 moles of sodium chloride per 1 liter, right? So instead of setting this up and saying, oh, I'm solving via proportion, I'm just going to go ahead and multiply those two things like you stated. And with that, liters will cancel, and we get moles, right? Well, our scales don't measure in moles, right, guys? So what do I need to go ahead and do? Convert to grams, which would be, what's the molar mass of sodium chloride? 58.44. grams of sodium chloride per mole. And how many grams is that? 7.01 grams of sodium chloride. All right, now, if you've not already stated how you prepare that, state that in your group out loud. At least try to get the verbiage and the language and the equipment right. And let's see if we can get that back together. 30 seconds. All right, Elizabeth's table. Can you guys be loud and proud and tell me how you prepare that? Give me like 2 or 3 steps.
Oh, take 7.1 grams of sodium chloride, put into a 1 centiliter flask.
What kind of flask?
Volumetric.
It's got to be volumetric, so that's a very specific one. Okay, so take that, put into a 100 milliliter volumetric flask, B flask. Okay. Fill with water to, I'm going to just keep saying etched line because I think you'll see it when you look at it on the volumetric flask a little bit better. Very good. Same exact process. What's the only thing that we will ever change in the how process? From problem to problem to problem, it's the only thing that will change. Okay, the amount, meaning maybe the solid grams we put in, or it could be the stock solution volume. That's what, like, for example, 16 molar stock solution would be like a really concentrated stock solution. What's another thing that will change? Right. The amount of H2O, you're right, but it's because of that volume changing, the volume of the B flask. Okay? All right, so 7 I heard, number 7 on the problem, on the 1 through 18, describe how you prepare that. Actually, I think I just answered that for you, doing these couple of questions, so number 7 you can go back to. All right, pull out a piece of paper, call it Molarity Rainbow Lab. I know some of you guys made more progress on problem set 15, 16 than others. You guys did see I printed that for you, right? It's on the back of the lecture notes that you were working with. You will not go to the lab if you are not done with 1 through 18. 100% done with 1 through 18. So if you still are wrapping up some of those, then you'll take probably 10 minutes and finish that before you go to the lab. Oh, here, Molarity Rainbow Lab, we'll do that. I'll go back to the other side in a second. Okay, so basically, all we're doing is practicing solution preparation today. We are doing 3 solution preps. So, whenever you get in your lab groups, you'll be working in groups of 3. 1 person will prep solution 1, 1 person will prep solution 2, 1 person will prep solution 3. But before you even dive into like messing with the glassware, you will do the math, meaning like I tell you what I want you to prep, you figure out how to prep it, just like we did for those 2 homework questions, exactly the same way, okay? So you're using 50 ml volumetrics in the lab. It might say 100, but I split it down to 50 because it makes more sense to use less substance than we need to. If you go over the etched line, you will remake your solution because it's incorrectly prepped. So we're going to really try to be very specific here. Use your, like, you know your wash bottle, it's got the little angled edge on it, the angled nozzle. You can be very specific with that. Answer all the analysis questions after you prepare your samples, after you prepare your final product. I will come around with a conductivity probe. What do you think conductivity probes measure? Conductivity, right? So you have a data table that's given to you on the lab sheet, and it asks for you to write down the conductivity. It's going to be in this weird unit called microsiemens per centimeter cubed or squared. So that's the unit. It's a weird unit. It just is really conductivity is high, medium, or low. This is due at the end of class, and I do think dividing and conquering, like I said, 1 person preps each solution would be great. I would help you with the use of technology. It won't be a problem. And I think that's all. We're not going to use temperature, so we're not going to do temperature. But at the end of this, after you make your 4 solutions, 3 of which are solutions, 1 is just water, you have a graduated cylinder, and that graduated cylinder is going to be a 10 ml grad cyl, and you're actually stacking your solutions. Okay, so you're going to put solution 1 in here, tilt it a little bit, run the next solution on the side, solution 2, solution 3, solution 4. So you're making a rainbow column because it's going to be a variety of colors. Okay, so follow the instructions very, very specifically. Groups of 3, Go. You can find it. It's called this in the lab notebook. It's actually called this in the lab notebook. Okay. You watch your video first, okay? Because you gotta. Mary, did you finish 1 through 18?
You said lecture problems, right? Or problems?
Lecture problems 1 through 18 need to be 100% done. Finish this the first one. Probably won't take you more than 5 minutes, okay? Of course, goggles. Yes, yes, yes. Goggles, goggles, goggles. Alright, fine. It's called solution molarity or prepping a solution. Okay. I lied to you. It's called preparing a solution to specific molarity. Preparing a solution to specific molarity. And you have to activate the preparing a solution to a specific molarity. Raise your hand if you can't find it.